So how the Automotive OS disrupts the way that we develop software. We've heard a lot about SDV, about Automotive OS, Vehicle OS, Car OS, whatever you want to call it, it's all the same. And we've also heard about the problems driving this. This is one of my favorite quotes here from CEO of Volvo. Today, the software is decentralized in a lot of black boxes, and we buy it from suppliers based on specifications. But when we want to change, you have to talk to suppliers. It is too slow. You note, it's not the technology that's the problem. It's the way of working. To have speed of development, that's the driving factor, time to market for software innovation. But also to guarantee high quality over-the-air downloads, you really need to secure the compatibility of all functionalities. And that is very difficult if you have the old structure. Compatibility, very important. That's where AutoSAR plays in. But still, it's a working mode problem. This is why we've heard so much about collaboration, about open sourcing, about partnerships, and I mean, you see all those partnerships popping up like mushrooms these days. Everyone wants to partner with everyone because no one can do it alone, and that's right. Defining the Automotive OS, and we've just seen a definition. Mine is slightly different, slightly better, of course. So let's look at how we define the Automotive OS. And a side note, we don't define it over technological stacks, because when I look at Automotive OS, what all the OEMs do, they all build something slightly different, but the value proposition is the same. First point, the Automotive OS is a software platform that abstracts the complex vehicle network of ECUs as one device. Regarding, like Android does for the smartphone, if an Automotive OS does the same thing for the vehicle as a whole. The Automotive OS manages, supervises, and updates the device. It's a holistic management level for the complete vehicle software. You don't look at state management of an individual ECU. Or you look at OTA for the entire vehicle, not just an individual partition. And this is what we've heard a lot as well, the Automotive OS enables an ecosystem by harmonizing the APIs against which functions are developed. You want to develop software independently and upload it to vehicles and sell software and get an app store for your car. Sell new functionality as Tesla does these days. And yes, there's a bit of technology. So this is pretty much in line with what Mark has just shown. We separate between 4 different layers when we look at the Automotive OS. On the bottom, there's what we call the core software, hardware-dependent software and operating systems. So AutoSAR OS, POSIX OS, hypervisors, switch firmware, this kind of stuff, HSMs. And we see a lot of fragmentation in the market these days. AutoSAR plays a very important role in this, but there's also alternatives. Same thing for middleware. Middleware is the part where you look at the management of individual partitions, of individual ECUs. So adaptive and classic AutoSAR are the typical examples for that. But you see DDS or ROS or Android. You see fragmentation in this. Platform services is the first level that actually raises some parts to the vehicle-wide level. So we're talking about vehicle-wide mode and health management. We're talking about vehicle-wide intrusion detection, vehicle-wide over-the-air update management. And this is where AutoSAR has also gone in with the UCM Master, for instance, or when we look at the IDSM specification for intrusion detection, that we can able to lift this up to the next level. And on top, you start developing applications. So lighting, driving, lighting, locking, charging, whatever you want to have there. Now, along with this, of course, you have the cloud connectivity. We've also seen that. That was called the Vehicle API in previous talks yesterday. And you do have, as Mark also put in, the question of how to develop this. So we all see the digital twin, the cloud-based development, all feeds into that story. It's all part of the story. What's really important here is, if you really want to get to a software platform, You need to introduce what we call here different kind of vehicle API, an API against which you develop your functions. You cannot have a different API set for each and every ECU. You're going to end up in maintenance hell. And the same thing on the bottom. If you want to separate the software platform from the hardware, you either do hardware abstraction or you control the variants that you have in hardware. That's what we see with all the partnerships between OEMs and semiconductor vendors popping up these days. Let's talk about life cycles. How often do you expect to see updates of a vehicle? In the future, not today. So, it's late, so I'm not going to do the raise of hands, but please stand up. Applications. Who thinks applications will be updated on a daily basis in the future? One. What about weekly? Oh, come on, it's too late for you guys. So, few weekly. What about monthly? That's already a big part. Years? No? Okay, it's way too slow, right. What about the Automotive OS itself, the software platform? Anyone thinking we should see daily updates? Weekly updates? A few monthly? Majority? Years? Oh, there's some years popping up. Hardware. Who wants to see hardware updates? So, I think we can skip the days and weeks, right? Who thinks we're going to see like releases of hardware upgrades on a monthly basis? Who thinks we will see hardware upgrades in the time frame of years? Will we see hardware upgrades in a vehicle? There's a few. Who says never? Good. What does it mean to separate life cycles of applications, of software platform, and hardware? Because what you've just said is, I expect that I can update my applications on a weekly to monthly basis, the software platform on a monthly to yearly basis, and never for your hardware, or with some few exceptions. Let's look at smartphones. I love this diagram. So I jumped across this on Statista. It shows the historical iOS compatibility of iPhone models. So you have the different iPhones in the different rows and the iPhone versions, the iOS versions in the columns. And it just took an extract out of it for illustration purposes. There's the full diagram if you want to have a look at it. The iPhone 6s is a very interesting example. It was initially released with iOS 9. The last version it received was iOS 15. That's 7 different versions of a software platform that one device received. Fun fact on the side, iOS 9 was roughly deprecated between iOS 10 and 11. There was one odd update a bit later on for fixing GPS functionality. But there was a deprecation of the software platform version. So that is separation of the life cycle of a software platform and the underlying hardware. Because you can bring a new version of the software platform on old devices. And there's another separation layer in iOS. The current version of TikTok, or at least the one that I screenshotted there in October of TikTok here, requires iOS 10 or later. The single version of of TikTok runs on iOS 10, 11, 12, 13, 14, 15, 16. There's not a separate version for iOS 10 or iOS 11. Imagine going to the Play Store and saying, well, I want to now download TikTok for iOS 12. Feels awkward, doesn't it? So there's separation of the application lifecycle from that of the software platform. Now, let's look at automotive. We are on the left side a lot of time still, and this is where the value proposition of an automotive OS kicks in. We do vertically integrated ECUs and provide frozen version support for 15 years. Isn't that awesome? And if you want to separate life cycles, because now we have frozen version support of applications, software platform, and hardware in one box, but we have different life cycles, that doesn't fit. You need to separate the development practices there. So you need to have continuous development for your applications. You need to have continuous development for your software platform, independent of the hardware platform, independent of the applications. That's the key to success to build an automotive OS, to enable a software-defined vehicle. So to quote Simon Sinek here a bit, so you need the infinite mindset. That is the infinite mindset of a software platform. That's very different from building an ECU project. When is the end of life of a vehicle and its software? 10 to 15 years. The software reaches end of life together with the vehicle. You have a car. I personally drive a 10-year-old car, and the software is still pretty much the same as when the car was produced. There's not going to be an update, and well, the software is going to be dead together with the car. There's no updates. There's no deprecation, nothing like that. When is the end of life of a software platform? When is the end of life of iOS? We know when it started with the first version of the iPhone. And yes, there's individual versions that deprecated over time. But a software platform doesn't have a targeted end date. You want to continuously develop for it. A software platform evolves over multiple generations of hardware. Single versions of the software platform deprecate over time. You have controlled deprecation. And applications are added or removed over the lifetime. This is what it means to get to a software-defined vehicle. This is what we want to achieve when we keep on saying, well, we want to upload functions and everything. Because otherwise, you're going to end up in maintaining software platforms that are bound to specific vehicles. Imagine taking latest car right now and putting the next software platform in 5 years. I've yet to see a single OEM, except perhaps Tesla, to achieve this. A software platform has no targeted end date. It evolves over time. It aims to generate new value in new generations. You update the software platform, it gets better. And it transcends the life of the hardware. It really is separated. What does it mean for us as automotive software community here? How we need to develop if we really want to get to a software-defined vehicle. First point, an automotive OS, a software platform that you want to have across the vehicle, is not built as part of an ECU project, because it's a product of its own. It is developed centrally as a software platform across generations of vehicles. Variants are minimized stringently. Imagine Apple introduced no variants of iOS for each and every variant of iPhone that they have. It would be insane. You can't maintain this. An automotive OS does not have a targeted end date. Single versions of it, yes, but if you now start to develop an automotive OS and say, well, yeah, and we're going to have SOP in 2025, and then we're done with this because then we start with the next version of that software platform, then it's not a platform, then it's an ECU project. The development, therefore, should favor long-term partnerships with joint commercial interests rather than supplier relationships with a dedicated project duration. This is the reason why we talk about collaboration, about open sourcing, about partnerships all the time. Because you need to be in it together in the long run. An automotive OS serves as a software platform across generations of vehicles and versions of functions. Standard APIs and maintaining version compatibility is key to efficient maintenance. This is something where AutoSAR currently brings in a standardization of APIs, but we have to recognize as AutoSAR as well that stability of APIs and backwards compatibility are first-class citizens in any software platform. Linux, never break userland, needs to be a maxim there as well. An automotive OS combines software assets with independent life cycles from multiple contributors. Collaboration platforms to develop, integrate, test, and iterate quickly across partners and able to innovate for the platform. Because we are in this together, and as Mark also said, there's not a single OEM or supplier or tier one that can manage this alone. So that was a not so technical last talk here. Happy to take any questions.